For a long time, I've been fascinated by the dense packing of BGA packages. Throughout my career, I've worked with various package types and built up the experience to hand solder these minute wonders of semiconductor engineering. But BGA always sat in the back of my mind, that one package I hadn't tackled yet. Well, curiosity got the better of me. I tracked down the last 3 available units of the STM32 G474 microcontroller, a device that strikes a great balance between processing power and peripheral count. And what better way to pair it than with the world's smallest OLED display at 60 by 32 pixels, alongside a suite of environmental sensors. I jumped straight into Altium for the schematic. I like to structure these using a branched approach. It keeps the documentation clean and gives you a clear picture of all the interconnects at a glance. The circuit is built around the STM32 G474 VEH6 in a TFBGA100 package with 0.8mm pitch. Not the easiest thing to hand solder. Paired with a UV sensor, a 9-axis IMU, an AQI air quality sensor, and a real-time clock. Since the Vision was always an off-grid wearable watch, I included a full battery circuit that I can charge using USB-C port, a charger, a buck boost converter, and an NTC thermistor to keep an eye on battery temperature during charging. Rounding it all out, a 6-way tactile switch for menu navigation, and a mini piezo buzzer. That's the hardware. Next up, PCB layout. So, this is a fairly simple 4-layer board, with the 2 inner layers used as reference planes for a clean ground and power distribution. The stack-up also includes impedance-controlled traces for the USB differential pair, important for signal integrity even on a board this small. Component placement is divided into 4 logical blocks. Top right has the buzzer and USB connector. Bottom right houses the battery charger and buck boost converter circuit, along with the LED indicators. The STM32 sits at the center of the board, with the 6-way tactile switch and reset button directly below it. On the left side, we have the voltage level shifter for the IMU and the remaining sensors, UV, AQI, and RTC. And the OLED screen sits right on top of the MCU, keeping everything compact. For assembly, the plan is to use a stencil to apply solder paste on the top layer, place the components, and reflow using a hot plate. The bottom layer passives get hand soldered afterwards. One deliberate design choice: no SMD connector for serial wire debug, just exposed pads. It saves a bit of cost, and the pads are perfectly functional for programming and debugging with a bit of careful probing. Next up, we actually get it fabricated. For fabrication, I went with JLCPCB, my go-to for personal projects. Good quality, fast turnaround, and hard to beat on price. About a week later, the boards arrived, and almost immediately I spotted a mistake. I'd forgotten to tent the vias, meaning they came back exposed. On most boards, that's a minor cosmetic issue. But these vias sit directly under the BGA right in the fan-out area. Exposed vias under a BGA are a serious problem. Solder can wick down into them during reflow, starving the balls of the material they need to form a reliable joint. So before I could even think about assembly, I needed a quick fix. I picked up a solder mask kit and carefully applied it over every exposed via under the MCU footprint. After painstakingly masking every exposed via under the microscope, one by one, making sure each was fully covered and cured, it was time for assembly. Stencil down, solder paste applied, components placed, and onto the hot plate. Then came the moment of truth, watching the paste reflow and hoping those 100 BGA balls were all making contact underneath, completely invisible, with no way to verify until you actually power it up. And here are the results. The board came up first time, a huge relief given everything riding on that one reflow. A big thank you to JLCPCB for sponsoring this video. Fast turnaround, great quality, and they never let me down. From here, the plan is to continue refining the firmware, pushing this little board to its full potential.